Alright, to check the linear dependence and independence of any linear combination, there is an authentic method, and that method is called Wronskian. Wronskian is a specific method. Always remember that Wronskian is related to determinants. So if you have several functions up to nth order like f1, f2, f3, f4 to fn, then Wronskian can be written as f1, f2, up to fn. Okay, so I told you that it is related about the determinants. So determinants and derivatives also. If you have function n up to nth order, then what you have to do, you have to take the derivatives up to n minus 1. That is a really important thing. So n minus 1 derivatives, and you have to take the determinant, write in the first row f1, column f1, second column is f2, third column is f3, to so on, last column is fn. Similarly, in the second row, first derivative, and its first derivative. Third row, second derivative of f1, second derivative of f2, second derivative of f3, and second derivative of fn. Alright, so up to, I told you, n minus 1 derivative. So last is n minus 1th derivative of f1 up to so on, f2 n minus 1th derivative of f2, and third derivative n minus 1th derivative of f3, to so on, last is fn, and that has n minus 1th derivative. So take the determinant of this matrix, like think, and to check that whether this combination or whether this determinant equals to 0 or not. You can judge whether it is linearly dependent or independent. So I'm going to tell you that first is, if this determinant, number 1, this Wronskian, basically we call it as Wronskian. If this Wronskian of all the functions, basically Wronskian means determinant, okay? So if this is not equal to 0, then we say that these functions are linearly independent. So in the last technique, all the c's, all the constants must be equal to 0. Then we say that it is a linear independent function. And if at least one c is 0, then we say that linearly dependent. In Wronskian, this combination, if this determinant is non-zero, then we say that it is a linearly independent function. And when this Wronskian is equal to 0, that means its determinant is equal to 0, then we say that these functions are linearly dependent functions. So very easy technique to judge that whether this linear combination is independent or not.